Next, let's work on exercise set from section 14.4. Here we will deal with tangent planes, function linearization, and then linear approximation, and then the differential. Okay, let's start. Which one should we do first? Maybe I do number 4 right away, and number 6. Okay, yeah, number 2 I think is too easy, huh? No fun. Okay, so we have number 4. We want to find the tangent plane. So we will need to find the z sub x first. Let me write down the function first. Z equals to xe to the xy at 2, 0, 2. By the way, this 2, 0, 2 here actually going we plug in z as a function of xy. Right, so 2 times e to the 0 times 2 e to the 2 times 0, that's 2 times e to the 0, that's 2. Okay, now that's the 2 that we get here. Okay, so what is c sub x? C sub x is e to the xy plus this guy times the derivative with respect to x, that will be xy e to the xy. C sub y will be x squared e to the xy. Now, so c sub x 2 comma 0 will be, that will be 1 plus 0, that's 1. C sub y at 2 comma 0, that will be 4. Okay, now if we remember, then the tangent plane is given by there are two ways to look at this though. The tangent plane, you can just think of that as a regular tangent plane, right? Which that it contains coordinate 2, 0, 2, and the factor normal to it is -1, -4, 1. Okay, that will give us -1 x minus 2 minus 4 y minus 0 plus 1 c minus 2 equals 0. Okay, z equals to 2 plus x minus 2 plus 4 y minus 0, which is another way to see the tangent plane, which is z equals to the value at that coordinate plus c sub x, x minus a, plus c sub y, y minus b. Notice that it matched that pattern. Okay, and of course, in that case, we simplify, we will get there will be x plus 4y only. Yeah, x plus 4y. That's the tangent plane. But yes, we have two different ways to do that. This is the way we did the regular plane in the past, okay, which if we solve for c, we will get the formulas that we have from this lesson anyway, 14.4. Okay, number 6. So c sub x will be 1 over x minus 2y times 1. C sub y will be -2 over x minus 2y. So c sub x at 3, 1, 3, 1 will be 3, 1, that's 1. And c sub y at 3, 1 will be -2. Okay, so the tangent plane will be 0 plus 1 times x minus 3 plus, oh, I'm sorry, minus 2 times y minus 1, okay, which will give us x minus 2y minus 3 plus 2 minus 1. Okay, next, explain why the function is differentiable at the given point. To show that the function is differentiable at the given point, I think what you need to show is only that the partial derivative exists and continuous in the surrounding functions, the surrounding of that coordinate, okay, exists and continues in the neighborhood of the point. Okay, let's do number 14 right away. Okay, we have f of xy equals to square root of x plus e to the 4y, and we want to see that as at 3, 0. Let's compute first what is the value at 3, 0. That's 3 plus e to the 0, that's square root of 4, that's 2. Okay, so the coordinate with the domain 3, 0 is 3, 0, 2. Okay, next, f sub x of xy will be 1 over 2 square root of x plus e to the 4y. But when we plug that in, f sub x of 3, 0, that will be 2 over 2. That's 1 over 2 times 2. That's 1/4. Right. Well, I see that this pattern is the same to this. So if I plug in 2 here, I get 1/4. Okay. I hope that simplifies your, you don't need to recompute that all over again. So the partial respect to y will be 4e to the 4y over 2 square root of x plus e to the 4y. Now, if I plug in 3, 0, that will give me, that will be 2 over 2 at the bottom. That's 4 times 1 at the top. That's 1. Okay, so the tangent plane will be 2 plus 1/4 x minus 3 plus 1 y minus 0, right? Okay, remember the tangent plane then being used as the linearization. Okay, so the linearization at xy at 3, 1 will be 3, 0. I'm sorry, not 3, 1. Will be 2 plus 1/4 x minus 3 plus, you know what? I should just compute it right away. What am I doing? So that's 1/4 x plus y plus 5/4. Okay, that's the linearization. Okay, now then next, verify the linear approximation at 0, 0. Let's do number 18. Number 18. So let's call our function f(x,y) equals to square root of y plus cosine squared x. So the partial with respect to x of xy is 1 over 2 square root of y plus cosine squared x times the derivative of cosine squared x respect to x, which will be 2 cosine x times negative sine x. Okay, which will give us negative sine 2x over 2 square root of y plus cosine squared x. Oh, by the way, what is f00? f00 will be 1, right? So f sub x at 0, 0, that will be 0. Now f sub y of xy will be, I think this is a simple one, over 2 square root of y plus cosine squared x. So f sub y at 0, 0 will be 1/2. Okay, so the tangent plane will be the value at 0, 0, the value of the function at 0, 0 plus 0 times x minus 0 plus 1/2 times y minus 0. Okay, which then the linearization becomes the realization becomes 1 plus 1/2 y, right? That's the confirmation. Okay, find the differential of the function. Let's see number 26 first. Number 26. U equals to the square root of x squared plus 3y squared. Okay, u sub x is 2 square root. We get used to do the derivative of square root, huh? Okay, so on the top we have 2x, so that becomes x over square root of x squared plus 3y squared. U sub y will be that will be 3y over square root of x squared plus 3y squared. Okay, so what is the differential of u? That will be u sub x times dx plus u sub y times dy, right? Okay, that will be x dx plus 3y dy over square root of x squared plus 3y squared. That's the differential. For number 26, let's do, I think it's reasonable to do number 30, right? Let's try. You know what? Let me move number 26 underneath. And then I can do number 30 on the right hand side. So L equals to xz e to the negative y squared minus z squared. So the partial with respect to x will be z e to the negative y squared minus z squared. Partial with respect to y will be, negative 2xyz e to the negative y squared minus z squared. Am I okay so far? Partial with respect to z will be same thing, huh? Negative 2. Oh, no, it's not. Negative 2xz squared e to the negative y squared negative z squared. Okay, so the differential of L will be partial of L respect to x dx plus partial of L respect to y dy plus partial of L respect to z dc. Okay, so that will be z e to the negative y squared minus c squared plus minus 2xyz e to the negative y squared minus c squared dy minus 2xc squared e to the negative y squared minus c squared. Oh, I'm sorry, I forgot the dx here. I think we can factor the z e to the negative y squared negative c squared, right? And then we get dx minus 2xy dy, right? Minus 2xc dz. Okay, that's the differential. Next one, if we have this function here with xy change from 3, -1 to 2.96, -0.95, find the values of delta z and dz. Now delta z, basically the change of the z value, okay, there's a 2.96 comma 0 -0.95 minus z 3 comma -1. Okay, the terminal points minus the initial point. Okay. Now this one you can just use calculator. Should I? I'm honestly very lazy. So I will just use calculator now right away. I mean, that's a calculator word to start with. Let me share my view with you. Okay, let me first compute z3 -1. z3 -1 means my x is 3 squared, and then minus xy 3 times -1, and then plus 3 times parentheses -1 squared. That's 15. So that will be something minus 15. Okay, something minus 15. Now 2.96 squared minus 2.96 times -0.95 plus 3 times -0.95 squared. 14.2811. 14.2811. When we subtract, we get -0.7189. Okay, so that's the actual change. Now, what is dz means? That's the differential. Okay, differential of z will be the partial of z respect to x dx plus the partial of z respect to y dy. Okay, that will be the 2x minus y dx plus negative y plus 6y dy. Okay, now then dc at 3 comma -1 will be equals to 2 times 3 minus -1 dx plus negative of -1 plus, I'm sorry, I think it should be x, huh? Not y. There should be x there. -3 plus 6 times -1 dy. So that's 7 dx plus -9 dy. Okay, now we see what is the dx, what is the dy, right? We see the dx and then dy. Let's do that aside. 2.96 -0.95. When we subtract by 3 comma -1, that's our dx dy, right? Okay, which will be -0.04 comma 0.05. Actually, to be more precise, we're supposed to write this using factor form, huh? Right? Okay, so then when I plug that in here, okay, dc at 3 comma -1 to that 2.96 -0.95, that will be 7 times -0.04 minus 9 times 0.05. What will that be? That's -0.28 minus 0.45. That's -0.73. Okay, see the difference? Okay, this is the actual error, while this is the estimated error. Okay, that's the estimated error. What I want to say, I wonder if you notice that this dz here, if you think about it, is we can rewrite that as, I'm talking about this guy here. This is actually z sub x comma z sub y dot dx dy. Okay, and if you have learned the gradient notation, then you will see this is actually the gradient of c dr, right? I wonder if you remember that. Well, anyway, that's what it looks like, right? Okay, let's see the last question, number 39. We have R, the total resistance of 3 resistors connected in parallel and with resistance R1, R2, R3 with this formula. So this has something to do with electrical engineering, huh? If the resistance are measured in ohms as R1, R2, R3 given there, with possible errors of 0.5% in each case, estimate the maximum error. Estimate the maximum error. So the error that we expect for R equals to what? Okay, I think what I will do, let's do the partial of R respect to, I will just do implicit differentiation with respect to R1. If I do implicit differentiation with respect to R1, or maybe I can do it in general, Ri, that will be negative 1 over R squared dr, maybe dou R to be more precise, dou Ri equals to negative 1 over Ri squared, right? In other words, negative 1 over R squared dou Ri, I'm sorry. So dou Ri will be basically R squared over Ri squared. Is it right? Okay. Now, then the differential respect to differential of R will be dou R1 dr1 plus dou R2 dr2 plus dou R3 dr3. Okay, and each of them will give us R squared over R1 squared. And the error for each Ri is 0.005, like 0.5% of each case, right? So the R squared over R1, R2 squared, 0.005 R2 plus R squared over R3 squared, 0.005 R3. Notice that I can factor R squared out. I can factor 0.005 also out, and I have 1 over R1 plus 1 over R2 plus 1 over R3, which is just another R. So we get 0.005 R. Okay. Now, of course, then if we want to find the actual value, we need to find what is the value of R for those numbers, right? So 1 over R is equal to 1 over 25 plus 1 over 40 plus 1 over 50. The LCD is 200, right? So that's 8 plus 5 plus 4. That's 17 over 200. So R equals to 200 over 17. Now, then the dr, therefore, will be at R1, R2, R3, 25, 40, and 50 is 0.005 times 200 over 17. That's 1 over 17. Okay, so if we have that possible error 0.5% for each Ri's, then the maximum error will be 1 over 17. Okay, that's it for this section.